Welcome to the sleepy Geographer channel, a quiet corner of the world, a place of stillness where the earth seems to have found a deep and lasting peace. If you were to walk here this evening, you might feel the solid, dependable ground beneath your feet and think it has always been this way. That these rolling hills, these ancient trees, this gentle stream are the permanent story of this place, but beneath this tranquility, a different story is being written, a story of restlessness and heat and immense patient power. For this serene landscape is a stage and the main character has not yet arrived. This is the story of the moments before the birth of a mountain of fire. This is the awakening of a sleeping giant. Before any peak pierces the clouds, before any river of fire carves a new path through the stone, there is only the deep, dark silence of the earth's crust. Here, miles below the soil we tread, the rock is cold, brittle and still. It is a world of immense pressure and perfect quiet, or so it seems. Deeper still, far beneath this brittle shell, lies the mantle, a realm of such heat and pressure that solid rock is not quite solid, but flows over centuries and millennia with a slow convective creep. It is the planet's great slow-beating heart, and from this deep, hot reservoir, a change begins. A plume of rock, hundreds of degrees hotter than its surroundings, begins a journey. It is not a rapid surge, but a slow, buoyant ascent, moving at a pace that would make the growth of a glacier seem frantic. It is the first, almost imperceptible stirring of a dream. This superheated rock, this magma, begins to migrate upward. It does not force its way with violence, but instead, it seeks out paths of least resistance. Tiny fractures, ancient fault lines, the weak seams in the planetary crust left by the shifting of tectonic plates. It infiltrates these spaces not like a bomb, but like water, seeking the cracks in a ceiling, a slow, persistent seepage of unimaginable energy. As it rises, the pressure upon it lessens. Gases that were once dissolved within it, water vapor, carbon dioxide, sulfur, begin to exsolve, to form tiny, separate bubbles. The magma itself changes, its chemistry shifting, crystallizing some minerals, melting others. It is an alchemical process happening in total darkness, a transformation on which the future landscape depends. Eventually, after a journey that may have taken hundreds of thousands of years, this ascending body of molten rock encounters a barrier it cannot immediately pass. The cooler, more rigid rock of the upper crust, and here it begins to pool. It accumulates droplet by droplet, surge by slow surge, in a vast underground reservoir. This is the formation of the magma chamber, the volcano's hidden heart, still silent, still deep beneath the slumbering valley. The landscape above remains oblivious. Flowers bloom, animals graze, rains fall and nourish the soil, but the ground is no longer passive. The slow, relentless inflation of the magma chamber begins to exert its influence. The earth above it, once perfectly stable, experiences a change so subtle that no human sense could detect it. The ground might begin to bulge, uplifted by the incredible pressure from below, rising by mere millimeters per year. The density of the rocks might change minutely, altering the local pull of gravity. The groundwater, circulating through deep aquifers, begins to heat up. New, faint mineral springs might appear where none were before. This is the giant not yet awake, but turning in its sleep. A deep geothermal sigh, then comes the first faint tremors. Not the violent shaking of a great earthquake, but something far more subtle. A low, constant hum of tiny fractures. The sound of the crust adjusting to the pressure, of rocks snapping under the strain, of the magma forcing the final few meters of its path. To sensitive instruments, they are known as harmonic tremors, a continuous, rhythmic seismic signal that is the unmistakable voice of moving magma. It is the whisper from the deep, a signal that the long stillness is coming to an end. And so in this quiet, unassuming valley, the stage is set. The architect has gathered its materials in a chamber of fire deep below. The land itself has begun to shift in anticipation. The old story of peace and stillness is nearing its final page. A new one, written in fire and stone, is about to begin. The sleeping giant is awakening, and it will not be quiet for long. In our last moment together, we stood in a quiet valley, feeling the first deep stirrings of a volcano, yet to be born. But to understand why that valley was chosen, why the earth decided to push fire towards the sky in that particular spot, we must pull our gaze back, far back. We must see our world not as a solid, finished sphere, but as a dynamic, restless entity, breathing a geology that is alive with heat and motion. The story of any single volcano does not begin in its own magma chamber. It begins with the planet's original fire and with the great slow dance of its skin. This is the context for all mountains of fire, the restless earth itself. If you could slice into our planet, you would find it layered like an onion or a cake baked over billions of years. But this is no static arrangement. At the very center lies the inner core, a solid sphere of iron and nickel under pressures so immense that the metal cannot melt, despite temperatures that rival the surface of the sun. It is a compressed star at the heart of our world. Surrounding it is the outer core, a swirling liquid sea of molten metal. This churning, conducting fluid is the source of Earth's magnetic field. That invisible shield that deflects the solar wind and protects the delicate film of life on the surface. But the true engine of volcanism, the primary source of the planet's inner restlessness, is in the next layer, the mantle. This is not a region of molten rock, as is often imagined. Instead, think of it as a solid, yet incredibly viscous material. Over the immense scales of geological time, it behaves like a fluid. It convects. Imagine a pot of thick soup on a very, very low simmer. The heat from the bottom causes the soup to rise slowly in great, languid blobs. As it reaches the surface, it cools and sinks back down, creating a continuous cyclical current. This is the mantle. Heated from below by the immense and primordial warmth of the core, it rises. As it nears the cool, brittle shell of the planet, it begins to sink again. This single, simple process, the transfer of heat from the hot interior to the cold space above, is the ultimate driver of everything we see on the surface. It is the reason continents drift, oceans open and close, and mountains, including volcanoes, are born. This convective creep is the Earth's great slow heartbeat, and it is this heartbeat that moves the plates. The crust of the Earth is not a single, unbroken eggshell. It is a patchwork of enormous rigid slabs called tectonic plates, each dozens of kilometers thick, floating on the ductile mantle below. They jostle, they jolt, they drift at a pace that is, poetically, almost exactly the speed at which your fingernails grow. A few centimeters per year. It seems like nothing. But multiply that movement by 1,000,000 years, and continents can cross oceans. Where these plates interact, the Earth reveals its dynamic nature. And it is at these boundaries that the weaknesses are formed, the doors through which the mantle's heat can escape. There are three main conversations that plates have with one another, and each sets the stage for volcanism in its own way. First, there are divergent boundaries where two plates are pulling away from each other. This happens most famously along the mid-ocean ridges, the longest mountain range on Earth, almost entirely hidden beneath the waves. As the plates separate, the mantle rock below, released from pressure, begins to melt. This magma rises to fill the gap, creating new oceanic crust in a continuous undersea volcanic process. It is a constructive, creative fire, building the very ground of the ocean floor. Second, there are convergent boundaries where plates collide. This is where the most dramatic and explosive volcanoes are born. When an oceanic plate, which is dense and heavy, meets a continental plate, which is buoyant and light, it does not win the head-on collision. Instead, it bends and begins to dive beneath the continent in a process called subduction. As this slab of cold, water-saturated rock plunges back into the hot mantle, it triggers profound melting. The water it carries lowers the melting point of the surrounding mantle rock, which then rises as vast quantities of magma, feeding a line of violent volcanoes on the overriding plate. The Andes, the Cascades, the Japanese archipelago, these are all volcanic arcs, born from the slow-motion descent of a tectonic plate. And third, there are the hot spots. These are the great mysterious plumes of intensely hot material that rise directly from the deep mantle, perhaps even from the boundary with the core itself. They are like the blowtorches of the planet, burning through the moving plates above them. As a plate drifts steadily over this stationary hotspot, a chain of volcanoes is punched through it one after another. The Hawaiian Islands are the classic example, a string of volcanic pearls across the Pacific, each island marking a moment in time when the Pacific plate was directly above that deep, stationary fire. So, when we return to our serene valley from the first chapter, we can now understand its context. It sits perhaps above a subducting plate, where melting is triggered dozens of kilometers below. Or maybe it lies directly over a hot spot, feeling the focused heat of a deep mantle plume. Or maybe it is in a region where the crust is being stretched and thinned, allowing magma to rise. The specific reason matters. But the overarching truth is this: the volcano being born there is not a random accident. It is a symptom, a vent, a necessary release valve for a planet that is cooling itself down. The fire that was there at the beginning, the heat that forged the world, is still there, and it must find a way out. The restless Earth, through the great grinding machinery of plate tectonics, simply provided the weakness. The path was opened, and the fire, as it always does, began its slow, inevitable ascent. For eons the pressure has built in the dark. The magma chamber, that vast subterranean reservoir, has swelled like a lung holding a final, immense breath. The rocks above it have groaned, bent, and fractured under the strain. They have whispered their distress in a language of tremors. But every patience has its limit. Every containment its failure. This is the moment of that failure. This is the birth. It does not always begin with a cataclysm. More often it starts with a sigh. A final, critical fracture opens in the ceiling of the chamber, a hairline crack that becomes a seam, that becomes a conduit. It is the first open pathway to the world above. And the magma, which has been waiting with the immense patience of molten stone, now has its invitation. Driven by the overwhelming pressure from below and buoyed by its own gaseous froth, the magma begins its final ascent. It squeezes into the new fissure, a glowing, incandescent river forcing its way through a crack that was, until this moment, cold and dark. As it rises, the confining pressure drops dramatically, and the gases dissolved within it, the same ones that have been slowly exsolving, now explode into action. They expand with violent force, fragmenting the magma into a fiery, chaotic mixture of gas, ash, and molten rock. This is no longer the slow, oozing material of the deep. It is becoming an eruptive mixture, its character transforming with every meter it climbs. The first sign on the surface is often not fire, but a deep, guttural roar, a sound that seems to come not from the air, but from the ground itself, as if the planet is clearing a primordial throat. The ground shakes more violently now, not with the subtle harmonic tremor of movement, but with the jarring percussive shocks of destruction. The once serene landscape is now a stage for a new and terrifying performance, and then it breaches. The nature of this first breath, this inaugural eruption, defines the very personality of the volcano to come. It is a declaration of intent, written in fire and rock. In one scenario, the Earth offers a more gentle, effusive birth. This happens when the magma is low in silica, fluid and runny, and the gas can escape relatively easily. The magma does not fragment explosively, but instead wells up to the surface as a river of incandescent liquid rock, lava. It might first appear as a small dome of fire, blistering up through a vent, then spilling over the edges like honey from an overturned jar. It glows with an inner light, a terrifying and beautiful orange red that pulses with heat. It hisses and crackles as it meets the cool air and the damp soil, sending clouds of steam swirling around its advancing front. This is a volcano being built by layering, by the slow, steady pouring of itself onto the landscape. It is a creator, patient and persistent, building its edifice one flow at a time. This is the birth of a shield volcano, but there is another, more violent beginning. This is for magmas that are thick, sticky, and choked with gas. For them, the journey to the surface is a struggle, and the release of pressure is not a gentle escape, but a detonation. When this magma finally reaches the surface, the pent-up gases do not simply bubble out, they explode. The magma is shattered into countless fragments. The result is not a river of fire, but a sky blackened with ash and rock. A colossal column of dark grey, black and brown material rockets upward, propelled by the furious expansion of superheated gas. Within this plume are particles of volcanic glass, crystals, and pulverized rock, all the shattered pieces of the magma that once was. This is an explosive or Plinian eruption. At the base, the ground is scoured by pyroclastic surges, dense, ground-hugging avalanches of hot ash and gas that race outward, incinerating everything in their path. As the material in the column cools, it begins to rain back down upon the landscape. Larger rocks called volcanic bombs fall first, thudding into the earth around the vent. Then, a steady, relentless snowfall of hot ash begins, blanketing the land in a layer of grey. This is a volcano being built by fallout, by the accumulation of its own explosive debris, layer upon layer, building a steep, conical mountain. This is the birth of a stratovolcano. Whether gentle or violent, the process has now begun. Where there was once flat ground, or a forest, or a hillside, there is now a vent, a hole in the earth from which the planet's interior is now exposed to the open air. With each passing hour, with each new pulse of magma from the depths, the edifice grows. A small cone of spatter and ash forms around the vent, a newborn mound on the skin of the earth. This is the volcano's infancy. It is raw, unpredictable, and full of a power it is only just learning to wield. The sleeping giant is not only awake, it has now spoken its first word, and that word is fire. The long, patient work of building a mountain has begun. We have witnessed the birth, the fiery breach, the first explosive cough, or the first effusive sigh that marks the beginning of a new mountain. But to believe the volcano is only what we see on the surface is to mistake a chimney for the entire factory. The true architect, the engine of this entire immense phenomenon, lies hidden in the deep, silent darkness. It is the magma chamber. Imagine a cavern, not of open space and echoing drips, but a cavern completely filled with a seething, molten, crystalline mush. This is not a hollow bubble, but a vast, sponge-like zone within the Earth's crust, a collection of interconnected pores and fractures, all saturated with incandescent rock. This is the volcano's heart. And like a heart, It has a rhythm of filling, pressurizing, and occasionally emptying. The story of the chamber begins with a supply line. From the deeper mantle below, a slow, persistent drip of magma feeds into it. This is not a rapid flow, but a geological intravenous feed, a constant, sluggish influx of new, primitive, molten rock. Each droplet carries with it the chemical signature of its depth, its history, its journey. Once inside the chamber, the magma does not sit idly. It begins a slow, alchemical transformation. It starts to cool. But cooling, for a complex mixture of molten minerals, is not a simple process of turning from liquid to solid. It is a process of differentiation, of fractionation. As the temperature drops, the minerals with the highest melting points begin to crystallize out first. Dense crystals of olivine or pyroxene, like dark, heavy snow, may begin to settle slowly to the bottom of the chamber. This settling changes the composition of the remaining liquid magma, making it richer in silica, water, and gases. It is a slow symphony of chemical self-segregation, a refinement process that can take thousands of years. Think of it as a vast subterranean kitchen. The initial magma from the mantle is a simple, rustic broth. But inside the chamber, it is simmered, reduced, and infused. Some ingredients are removed, others are concentrated. The chef, gravity and thermodynamics, is patient. The recipe that eventually makes its way to the surface, whether it becomes a fluid basalt or a viscous gas-charged rhyolite, is determined entirely by what happens in this deep, hot kitchen. And then there are the gases: water vapor, carbon dioxide, sulfur dioxide. These are the volatile spirits trapped within the molten rock. While the chamber is deep and under immense pressure, these gases remain dissolved, invisible. But they are the most restless ingredients. They are the pressure cookers within the pressure cooker. As the magma evolves and becomes more silica-rich, its ability to hold these gases diminishes. They begin to exsolve, to form tiny, separate bubbles, creating a froth within the chamber. This is like the slow, invisible formation of bubbles in a bottle of champagne, long before the cork is popped. The volume of the magma increases, and with it, the pressure on the solid rock walls of the chamber itself. This leads to a profound and visible effect on the world above. The ground above the magma chamber begins to swell. It is a phenomenon known as inflation. The entire landscape over months or years rises by centimeters or even meters, like bread dough slowly proving. This is the volcano taking a deep, preparatory breath. It is the most telling sign that the architect beneath is active, its chamber filling and pressurizing, storing the energy for a future release. The chamber is not a monolith. It is a dynamic, complex, and often layered system. There can be multiple chambers at different depths, each with its own chemical character, each feeding different types of eruptions. A deep chamber might feed a gentle, effusive flow, while a shallower, more evolved and gas-charged chamber might be the source of a cataclysmic explosion. The plumbing of a volcano is an intricate, multi-storied workshop, and the magma chamber is its central hall. This hidden architect is therefore the master of the volcano's destiny. Its size determines the scale of an eruption. Its composition dictates the volcano's violence or its gentleness. Its pressure dictates the timing. Everything we see on the surface, the shape of the mountain, the explosivity of the eruption, the very lifeblood of the lava flows, is merely a reflection of the deep, slow, and majestic processes happening within this chamber of fire. It is the silent partner in the volcano's existence. The stage manager working in the darkness, while the actors, the lava, the ash, the pyroclastic flows, perform in the light above. To understand a volcano is to listen for the quiet, immense heartbeat, felt not in our ears, but in the very rising of the ground beneath our feet. The architect is always at work, deep below, in the fiery crucible where the earth remakes itself. From the hidden architect in the magma chamber, the fire is born, but it does not always take the same form. Just as different artists, given the same materials, will create vastly different works, so too does the Earth, with its palette of molten rock and gas, sculpt mountains of startling variety. The volcano we see on the horizon, its silhouette, its steepness, its very presence in the landscape, is not an accident. It is a direct and beautiful consequence of the fire that built it. It is the shape of the fire's personality, frozen in stone. The first, and in many ways the most gentle of these personalities, belongs to the shield volcano. Imagine a warrior's shield laid flat upon the ground. Not the steep, angled shield of a knight, but the broad, convex shield of an ancient warrior, wide, vast, and gently domed. This is the form. These are the volcanoes built not by violence, but by persistence. They are born from magma that is itself inherently calm. It is basaltic magma, low in silica, which makes it fluid and runny like honey or motor oil. It is also relatively poor in trapped gases, allowing them to escape without explosive force. When this magma reaches the surface, it does not explode, it effuses. It pours out in long, sinuous rivers and broad, thin sheets. Each flow may be only a few meters thick, but they can travel for dozens of kilometers. Over thousands of years, flow after flow, layers upon flow, the mountain grows not upward in a dramatic peak, but outward in a vast, sprawling dome. The classic example is the Hawaiian Islands. Mauna Loa, the largest volcano on Earth, if measured from its base on the seafloor, is a shield volcano so massive that it has depressed the oceanic crust beneath it. To stand on its slopes is to experience a profound sense of space. The summit is often so far away and so gradual that it is almost imperceptible. This is the patience of the Earth, written on a colossal scale. Then, there is the shape we most often picture when we hear the word volcano. The perfect, soaring, often snow-capped cone. This is the stratovolcano, also known as a composite volcano. It is the dramatic counterpart to the shield's serenity. Mount Fuji, Mount Rainier, Mount Vesuvius. These are the icons, the postcard peaks that command awe and define skylines. Their majestic form is a direct result of a conflicted and violent inner life. The magma that feeds a stratovolcano is andesitic to rhyolitic, high in silica, which makes it thick and sticky, like toothpaste, and it is incredibly rich in dissolved gases. This is a recipe for tension. The thick magma clogs the vent, trapping the gases until immense pressure builds. The result is not a gentle pour, but a cataclysmic explosion. These volcanoes erupt in a dramatic cycle. One day they might unleash a towering column of ash and pumice, a Plinian eruption that rains hot rock and fine particles over the countryside. The next they might follow it with a slower, more cautious oozing of a thick lava dome that plugs the vent once more, setting the stage for the next explosion. This alternating rhythm, explosive fallout followed by lava flow, explosive fallout followed by lava flow is what builds the classic cone. The ash and pumice from the explosive phases fall close to the vent, creating loose, steep layers. The occasional lava flows then act like mortar, cementing these loose layers together and creating a strong interleaved structure, a stratovolcano. This layering gives it both its great height and its steep, elegant slopes. It is a mountain built by both fire and fury, a monument to the Earth's capacity for both creation and destruction in the same breath. And then there are the ephemeral artists, the short-lived sparks of the volcanic world, the cinder cone. If shield volcanoes are epic novels and stratovolcanoes are dramatic trilogies, cinder cones are fiery haikus. They are the most common type of volcano, but also the smallest and most transient. They are born from a single, often relatively brief, eruptive episode. Typically, gas-rich basaltic magma erupts explosively, but not with the sustained fury of a Plinian eruption. Instead, it fountains. Imagine a fiery geyser spraying molten rock into the air. This lava is shot into the sky, where it cools and solidifies in flight, falling back to Earth as dark, vesicular chunks of rock called cinders or scoria. These cinders, some the size of pebbles, others the size of cars, pile up around the vent, creating a perfectly symmetrical, steep-sided cone with a distinct, bowl-shaped crater at the top. They are like piles of black sand built in a geological instant. Paricutin in Mexico is the famous example, appearing in a farmer's cornfield in 1943 and growing to over 1,300 feet within a decade before falling silent. They are the stark, simple expression of a single, fiery idea. From the vast, gentle slopes of the shield to the layered, dramatic cones of the stratovolcano to the simple, poignant forms of the cinder cone, we see a clear language. The fluid, gas-poor magma builds wide, sprawling landscapes. The viscous, gas-charged magma builds tall, elegant, and dangerous peaks. The brief, fountaining magma builds small, perfect hills. Each volcano, therefore, is a testament. Its shape is a storybook, its slopes a record of every eruption that built it. To look at a mountain on the horizon and recognize its form is to understand the nature of the fire that sleeps within. It is to read the first chapter of its story, written not in words, but in the enduring architecture of stone. Before a volcano speaks with fire, it speaks in a subtler language. It does not remain silent until the moment of its eruption. Instead, it whispers, it groans, it sighs. It offers a chorus of warnings to those who know how to listen. For volcanologists, the mountain is never a silent monolith. It is a living entity, and its voice is a complex conversation of physics and chemistry, written in the trembling of the earth and the chemistry of the air. The most fundamental of these voices is the tremor. Deep below the surface, as magma forces its way through fractures and conduits, it generates a constant, low-frequency vibration. This is not the sharp jolt of a tectonic earthquake, but a sustained, rhythmic hum, a harmonic tremor. It is the sound of the mountain's engine idling, the steady pulse of moving molten rock. To sensitive seismometers scattered across its slopes, this tremor is as distinct as a fingerprint. An increase in its intensity or frequency is the mountain clearing its throat, a sign that the pathways are pressurizing, that the magma is on the move. It is the first deep note in the prelude to an eruption. Alongside this constant hum are the sharper, more brittle voices of the rock itself. As the magma chamber inflates, the immense pressure strains the solid rock containing it. This strain becomes unbearable and the rock fractures. These fractures generate small, shallow earthquakes, swarms of them, their epicenters clustering directly beneath the volcano. It is the sound of the stone prison breaking, the shattering of old faults to make way for the new ascent. Listening to these quakes, plotting their location and depth, is like watching an army of tiny chisels carving a path to the surface in real time. But the mountain's voice is not only felt through the ground, it is also breathed into the air. As magma rises, the dissolved gases within it begin to separate, seeking escape. The volcano begins to exhale. Fumaroles, steam vents on its flanks, start to billow more vigorously. The composition of these gases changes in a telling way. Scientists with instruments that can sniff the air from a safe distance watch for the ratio of certain gases, like sulfur dioxide to carbon dioxide. An increase in sulfur dioxide, a gas that resolves from magma at shallower depths, is a strong indicator that fresh, volatile-rich magma is approaching the surface. It is the mountain's breath growing hotter and more acrid, a chemical whisper of what lies beneath. Perhaps the most silent, yet most visible, of the volcano's voices is the language of its own shape. As we learned of the magma chamber, the ground itself begins to speak. Using technologies like GPS and satellite-based radar, scientists can measure the inflation of the volcano's flanks with millimeter precision. The entire mountain may be swelling a slow, colossal breath in. This ground deformation is the most unambiguous statement of the pressure building below. It is the mountain saying without a sound, "I am full, I am straining." In some cases, this bulging can be dramatic, entire slopes shifting outward by meters, a visible terrifying portent of a lateral blast, as was the case with Mount St. Helens. Listening to this chorus of voices, the harmonic tremor, the earthquake swarms, the changing gas emissions, the deforming ground, is the science and art of volcanic forecasting. It is not about predicting an eruption with the certainty of a clock, but about reading the vital signs of a living landscape. It is a practiced, careful interpretation. A sudden spike in tremor followed by a rapid increase in sulfur dioxide and a shallowing of earthquake hypercenters is the mountain speaking in clear, urgent sentences. Yet for all our technology, the volcano retains an element of mystery. Sometimes the voices fall silent before the main event, a deceptive calm before the storm. Sometimes the mountain speaks all its warnings, yet decides not to erupt, the pressure finding some other, hidden release. To live in the shadow of an active volcano is to live with this ongoing conversation. The low hum of the seismometer in the background, the daily gas measurements, the periodic satellite pass that measures the bulge. These are the translations of the mountain's voice. It is a dialogue between the immense, ancient power of the earth and the quiet, persistent curiosity of those who listen. The volcano is always speaking. Our task is not to command it, but to understand its language, to heed its warnings, and to respect the story it is telling. One tremor, one breath, one slow shift of the ground at a time. We have learned the language of the volcano's voice, a prelude often spoken in tremors and gasps. And when that voice finally roars, it is easy to see only the destroyer. The rivers of fire that consume forests, the clouds of ash that bury landscapes. But to focus solely on this aspect is to miss half of the story, the most fundamental half. For the volcano is, above all else, a creator. It is the primary architect of our planet's surface, the great forge where new land is born from the furnace of the earth itself. Nowhere is this creative power more starkly beautiful than in the middle of the ocean. Picture the abyssal plain miles below the waves, a realm of perpetual darkness, crushing pressure, and soft sediment. Here, on the seafloor, a hot spot, a plume of intense heat from the deep mantle, penetrates the oceanic plate. Or perhaps at a mid-ocean ridge, the plates are pulling apart. In either case, the result is the same. Magma erupts. The first eruptions are entirely submarine. The immense pressure of the overlying water suppresses violent explosions. Instead, the lava behaves in strange, beautiful ways. It might extrude in vast, pillow-like forms, each lobe swelling from the vent and instantly crusting over in the cold water like a slow-motion blob of toothpaste. Or it might form sheets and flows that stack upon one another. For years, for centuries, this underwater construction continues, a silent, hidden building project of colossal scale. The volcano grows, layer by layer, flow by flow, until its summit begins to approach the surface. This is the moment of birth. The water pressure can no longer contain the violence of the eruptions. The magma, meeting the lower pressure of the shallower depths, now explodes into steam and fragmented rock. A violent churning cauldron appears at the surface, a Surtsean eruption named for the island of Surtsey off Iceland. For a time, it is a battle between fire and water, a plume of dark steam and ash roaring upward from the waves. And then, one day, the battle subsides. The eruptions transition, and a new steaming island of black rock and ash stands where there was only open ocean. It is a moment of pure genesis. The first land, raw, sterile, and completely new to the world. The volcano has, quite literally, expanded the map. The Hawaiian Emperor Seamount Chain is the quintessential example of this process. Each island in that long, graceful arc across the Pacific, from the still-growing Loihi Seamount deep below the waves, to the vibrant, active Big Island of Hawaii, to the older, more eroded islands like Kauai, represents a moment in time. Each was born as the Pacific Plate drifted northwest over a stationary hotspot. The volcano built an island, the plate carried it away from the magma source, and the fire moved on to build the next. It is a conveyor belt of creation, leaving a trail of new land in its wake. But this forging is not confined to the ocean. Iceland is a different kind of masterpiece. It is not a single island born from a hot spot, but a vast landmass built directly atop the mid-Atlantic ridge, where the North American and Eurasian plates are pulling apart. Here, the volcanic activity is constant and immense. The entire island is a product of this divergence, a place where new crust is being created so voluminously that it has built a country-sized plateau above the waves. To stand in Iceland's lava fields is to stand upon the very seam of the planet, on land that is, geologically speaking, still warm from the forge. On the continents, the process is no less vital. The Andes, the Cascades, the mountains of Japan, these stratovolcanoes are not just features on the continents. They are actively adding to them. Each eruption, each lava flow, each layer of ash contributes new material to the continental mass. The rich volcanic soils that drape the flanks of these mountains are the broken-down remnants of this new rock, creating some of the most agriculturally productive land on Earth. The volcano gives the land its fertility, its substance. This new land, whether a solitary island in a vast ocean or a new ridge on a continent, does not remain barren for long. It begins its own slow journey into life. The first colonizers are hardy indeed. Wind-blown spores of mosses and lichens find a purchase in the mineral-rich rock. Seeds carried by birds or the sea take root in sheltered crevices. Rainwater pools and microorganisms begin their silent work. Over decades and centuries, the sterile rock is transformed into a new ecosystem, a cradle for life built upon a foundation of fire. In this grand, geological perspective, the destructive eruption is but a momentary event in a much longer creative cycle. The volcano is the planet's way of renewing itself. It is the mechanism by which the Earth grows, evolves, and replenishes its skin. The fire that consumes is the same fire that builds. So when you look at a map and see an island or gaze upon a fertile mountain valley, remember the forge. Remember the slow, patient accumulation of rock, the battle between water and fire, the steady addition of new substance to the edges of our world. The volcano does not just shape the landscape, it literally builds it from the inside out. It is the Earth's most fundamental artist, and its masterpiece is the very ground beneath our feet. From the forge that builds new land, we now turn to a different kind of creation, one born of utter destruction. We have seen the gentle lava flows and the violent pyroclastic surges, but there is another product of the volcano's fury that is perhaps the most far-reaching of all. It is not fire nor stone, but something more ethereal, volcanic ash. This is the material of a Plinian eruption, the kind that can rewrite the chemistry of the sky and, in falling, create a strange and silent new world on the ground. The journey of this ash begins in the heart of a cataclysm. When a volcano like Mount St. Helens or Pinatubo or the ancient Krakatoa enters its most violent phase, it unleashes a Plinian column. Named for Pliny the Younger, who witnessed and documented the eruption of Vesuvius, this is the ultimate expression of a volcano's power. A jet of superheated gas, pumice, and ash rockets straight up from the vent, not for hundreds of meters, but for tens of kilometers. It punches through the troposphere and into the stratosphere, creating a towering, anvil-headed cloud that can be seen for hundreds of miles. This is the volcano's exhalation on a planetary scale. The ash itself is not like the soft, organic soot from a fire. It is finely ground rock. It is mineral. It is composed of tiny, sharp shards of volcanic glass, fragmented crystals, and pulverized pre-existing stone. Each particle is razor-edged, abrasive, and incredibly hard. When this column reaches the stratosphere, it encounters the high-altitude winds, the jet streams that circle the globe. Here, the heavier particles begin their slow, inevitable descent, but the finest ash and, more importantly, the gaseous sulfur dioxide are caught in this aerial river. They will travel around the world. The immediate impact on the regions downwind is apocalyptic. The sky darkens at noon. The sun becomes a dull copper-colored disk and then vanishes entirely. The ash begins to fall, a dry, grey, silent snow that smells of sulfur. It smothers everything. It accumulates on roofs, causing buildings to collapse under the unexpected weight. It clogs machinery, contaminates water supplies, and renders the air unbreathable, a gritty poison to the lungs. Agriculture is annihilated for a season. Crops are buried, and the light for photosynthesis is extinguished. For the communities living in the shadow of such an eruption, the falling ash is a funeral shroud. But the story does not end at the regional border. The finest particles and the sulfur dioxide gas now injected into the stable stratosphere have a different destiny. The sulfur dioxide slowly combines with water vapor to form a haze of tiny sulfuric acid droplets. This veil of aerosols can persist for years, forming a reflective screen around the entire planet. This screen does two things. It creates spectacular, blood-red sunsets across the globe, and it scatters and reflects a fraction of the incoming sunlight back into space. The result is global cooling. History holds stark examples. The 1815 eruption of Mount Tambora in Indonesia was so colossal it led to the year without a summer in 1816. Snow fell in New England in June, frosts killed crops across Europe in July, and widespread famine followed. The planet's average temperature dropped by several degrees. A volcano in the tropics had, for a time, imposed a winter upon the entire northern hemisphere. This is the volcano's reach. An event on one island can whisper a command to the global climate, dictating harvests and histories thousands of miles away. In our modern world, this ash presents a different, more immediate danger to our interconnected civilization, aviation. A jet engine operating at high temperature is designed to ingest air. If it ingests volcanic ash, the fine glass particles melt inside the combustion chamber, coating the turbine blades and fuel nozzles with a cement-like substance. This can cause a complete loss of engine thrust. Furthermore, the ash sandblasts windows, clogs, sensors, and disrupts avionics. The 2010 eruption of Eyjafjallajökull in Iceland, a relatively modest event, grounded European air travel for almost a week, stranding millions and causing billions in economic losses. A powerful demonstration of our vulnerability to this ancient force, and yet here lies the profound paradox. This agent of destruction, this bringer of famine and global disruption, is also one of the Earth's most powerful fertilizers. After the initial devastation, the ash that blankets the land begins to weather. Rain and time break down the sharp, glassy particles. They release their mineral wealth, potassium, calcium, magnesium, phosphorus, and a host of trace elements directly into the soil. Volcanic ash creates some of the most fertile, nutrient-rich land on the planet. The slopes of Vesuvius, which were buried and destroyed in 79 AD, are now home to thriving vineyards and orchards. The plains around Mount Merapi in Indonesia are densely populated because farmers know the soil, regularly replenished by ash, will yield abundant crops. The destruction is temporary, but the fertility it imparts can last for generations. So, the ash that falls like snow is a substance of profound duality. It is a regional killer and a global climate driver. It is a hazard to our modern machines and a blessing to the ancient practice of agriculture. It represents the volcano's power to both take away and to give. It is a reminder that on our planet, the very forces that can erase a landscape are often the same ones that prepare the ground for a richer, more vibrant life to come. The grey shroud is not an end. It is a difficult, trying but necessary beginning. Of all the volcano's expressions, there is one that feels most elemental, most primal. It is not the sudden violence of an explosion, nor the towering plume that darkens the sky. It is something slower, more deliberate, and in its own way more inexorable. It is the river of fire, the lava flow. This is the volcano in its most patient and persistent mood. After the initial explosive phase has cleared the vent, or in the case of a shield volcano from the very beginning, the magma that reaches the surface is often fluid and gas-poor. It does not fragment into ash, but wells up as a liquid, a molten rock that obeys the simple, relentless pull of gravity. It begins to flow. The speed of this advance is what gives it its unique character. This is not a flash flood. It moves at a walking pace, sometimes slower. You could outwalk it, outrun it with ease. And yet its slow movement is not a sign of weakness, but of utter, unstoppable certainty. It does not need to be fast. It simply is. It advances like a tide of light, consuming everything in its path, not with rage, but with an indifferent, thermal gravity. To stand before it is to understand the meaning of inevitability. As it flows, its surface tells a story of rapid cooling. Contact with the air forms a thin, flexible skin on the flow, which wrinkles and folds into ropey, billowing shapes. This is pahoho, a Hawaiian word that describes lava that looks like coiled rope or spilled syrup. It can hiss and crackle as it moves, the solid crust breaking and reforming over the molten interior. It is a beautiful hypnotic form, but not all lava is so graceful. When the same molten rock is more charged with crystals and gas bubbles, its skin becomes thick and brittle. As the flow moves, this skin breaks into a chaotic, jagged, clinking mass of sharp fragments. This is a word that evokes the painful, rough sound of walking across it barefoot. An AR flow is a moving mountain of broken glass and rock, tumbling and grinding over itself, a destructive, abrasive cascade. Whether smooth pahoho or rough AR, the effect on the landscape is the same. The river of fire does not push things aside, it embraces them. A forest in its path is not flattened but consumed. The intense heat, often exceeding 2000 degrees Fahrenheit, instantly vaporizes the moisture in the trees, causing them to burst into flames that are quickly swallowed by the advancing front. The lava does not burn the forest down. It digests it, leaving only a ghostly outline of carbonized wood for a moment before it too is buried under meters of new rock. It swallows houses, roads, and entire towns. It fills valleys, dams, rivers, and creates new, temporary lakes. When it finally reaches the ocean, as it so often does in places like Hawaii, it creates a new, violent frontier where fire meets water in a colossal, steaming explosion, adding yet more land to the coastline. In the immediate aftermath, the landscape it leaves behind appears to be one of utter sterility. A new land of black, twisted rock, a scar upon the earth that seems as barren as the surface of the moon. There is no soil, no life, only the hardened skin of the flow, which can take years to cool completely in its deepest parts. It is a canvas wiped completely clean. But herein lies the great paradox of the river of fire, the same paradox we see with ash, but rendered here in solid stone. This apparent destruction is the first step in creating the most fertile soils on our planet. The rock that makes up lava flows, basalt, is incredibly rich in minerals. It contains a wealth of nutrients essential for plant life: iron, calcium, magnesium, potassium, and phosphorus. But these nutrients are locked away within the hard, volcanic glass. The river of fire brings the fertility, but it is in a form that life cannot yet use. Then the slow, patient work of the atmosphere begins. Rain, wind, and the cycle of freezing and thawing start to break down the rock. This process, called weathering, is achingly slow. It can take centuries, even millennia, for a robust soil to form. But once it does, it is a soil of unparalleled richness. The broken-down volcanic material creates a deep, mineral-dense loam that holds water well and provides a perfect bed for roots. The flanks of volcanoes across the world, from the slopes of Mount Etna in Sicily, famed for its vineyards, to the coffee plantations growing in the volcanic soil of Guatemala, to the endless rice fields on the ash and lava plains of Java, are testament to this eventual bounty. The river of fire destroys the existing ecosystem, but in doing so, it lays the foundation for a future one that is often more diverse and more vigorous than what was there before. The river of fire, then, is a lesson in deep time. Its advance is slow to our eyes, and its transformation from a sterile wasteland to a cradle of life is slower still. It teaches that destruction and creation are not opposites, but 2 points on a very long, continuous circle. The same molten force that buries a forest under black rock is, in that very act, preparing the ground for forests yet to come. It is the planet's way of recycling, of renewing itself from the bedrock up. The river of fire does not just flow over the land. It becomes the land itself, a fertile promise written in stone and cooled by time. We have witnessed the patient architecture of shield volcanoes, the global reach of ash clouds, and the inexorable advance of lava rivers. But there is another aspect of a volcano's power that stands apart. It is not slow, it is not patient, and it offers no chance of escape. It is the most deadly and devastating force a volcano can unleash. This is the pyroclastic flow. The term itself is a stark, technical description of something almost unimaginable. Pyro meaning fire, clastic meaning broken. A flow of broken fire. But this name barely does it justice. It is not merely a flow, it is a ground-hugging hurricane of superheated rock, gas, and ash. It is a density current, a fluid avalanche of solid particles so hot they glow with incandescent rage, suspended in a searing atmosphere of toxic gas. Its birth is often tied to the collapse of a towering eruption column. When the jet of ash and gas shooting from the vent can no longer support its own immense weight, or when a growing lava dome becomes unstable and gives way, a part of the column simply falls back to Earth. It does not fall as a rain of separate particles, but as a coherent, fluidized mass. In that moment, it transforms from a vertical plume into a horizontal, topographically controlled torrent of destruction. Other times, it can blast directly from the flank of a volcano in a directed explosion, as happened at Mount St. Helens, when the entire north flank of the mountain failed and released a lateral blast that was, in essence, a massive, focused pyroclastic flow. Once unleashed, its behavior is what makes it truly inescapable. It does not follow the whims of the wind. It is driven by gravity. It does not flow over the landscape like water. It intimately molds itself to it, pouring down valleys and racing over ridges with a terrifying, intelligent malevolence. It moves at speeds that defy comprehension, anywhere from 80 to over 400 miles per hour. At its upper range, it is faster than a Formula One car, faster than a descending airliner. It can cross dozens of kilometers in a matter of minutes. No human, no vehicle on the ground can outrun it, but its speed is only one part of its horror. The temperature within the heart of a pyroclastic flow is what seals its absolute lethality. The gases and rock fragments are typically between 400 and 300 degrees Fahrenheit. At the upper end, this is heat sufficient to melt glass, lead, and copper. it instantly incinerates all organic matter in its path. Trees, buildings, and living beings are not just burned. They are carbonized, reduced to shadows and ash in a fraction of a second. The oxygen in the air is displaced by toxic, searing gases, carbon dioxide, hydrogen sulfide, sulfur dioxide. The lungs of any creature caught in its path are scorched and poisoned before the conscious mind can even register the heat. Perhaps the most chilling aspect is its internal physics. The flow is a fluid, not because of liquid rock, but because the intense turbulence and the expanding gases at the base keep the solid particles in suspension. This creates a low-friction, buoyant cushion that allows it to travel so far, so fast. Some flows are so intensely hot and energetic that they can even climb uphill, surging over topographic barriers in a final, contemptuous defiance of the very laws that gave them motion. The historical record is scarred with their testimony. The destruction of St. Pierre in 1902, where a single pyroclastic flow killed nearly 30,000 people in minutes, leaving only 2 known survivors. The burial of Pompeii and Herculaneum in 79 AD, where the flows and surges preserved the final moments of a civilization in a ghastly, perfect cast. At Pompeii, the falling pumice and ash suffocated many. But it was the pyroclastic surges that followed, the leading edge of the flows, that delivered the instantaneous thermal shock that carbonized bodies and sealed the city's fate. To be caught in a pyroclastic flow is to be erased. There is no defense, no shelter. It is a force that operates on a scale and at a speed that transcends human experience of disaster. It is the volcano's ultimate argument, a final, unequivocal statement of its dominion over the landscape. To study it, then, is not to seek a way to withstand it, but to understand it well enough to never be in its path. The science of mapping its potential routes, of monitoring the bulging domes and trembling slopes that presage its birth, is a discipline born of profound respect. It is the only form of deference possible in the face of such power. The pyroclastic flow is a reminder that our planet possesses energies that can, in an instant, reset the clock on a landscape and on the lives it supports. It is a humbling, terrifying, and awesome manifestation of the Earth's raw, unyielding power. It is the fire that does not just burn, but annihilates, and in its wake leaves a silence more profound than any other on Earth. We have journeyed through the heart of fire, across plains of lava, and through clouds of incandescent ash. But our planet is a world of contrasts, and it reserves some of its most dramatic geological performances for the stage where its most opposing forces meet. This is the realm where fire dons an icy coat. This is the world of glaciovolcanism. Imagine the immense, slow-moving weight of a glacier, hundreds of meters thick. Now imagine beneath it the restless heat of a magma chamber beginning to stir. This is not the classic volcano reaching for the open sky. This is a volcano waking to find itself buried, entombed in a prison of ice. The conflict that follows is one of the most explosive and creatively destructive on Earth. The drama begins in total darkness under crushing pressure. Magma rises from the depths and encounters not air, but the frigid, solid ceiling of the glacier's base. The initial contact is a violent negotiation of energy. The intense heat of the magma, which can exceed 1,200 degrees Celsius, instantly flash boils the ice. But the weight of the overlying glacier creates a confining pressure that prevents the water from simply turning to steam and escaping. This pressurized, superheated water seeks any weakness, fracturing the surrounding rock and ice in a process known as hydrofracturing. The result is not a gentle melting, but a phreatomagmatic eruption, a steam-driven explosion. When the pressure finally exceeds the strength of the icy lid, the volcano erupts. But it does not send a tall, ash-rich column high into the atmosphere. Instead, it unleashes a violent, dark and wet plume of steam, molten rock, and pulverized ice.
This is a different kind of fury.
The molten rock is instantly quenched by the meltwater, shattering into billions of tiny glassy fragments, creating a fine, abrasive ash unlike any other. These eruptions are often short-lived, pulsing, and exceptionally violent, as the volcano fights for every breath against its icy shroud. The landscape this struggle leaves behind is as unique as the process itself. One of the most distinctive landforms is the Tuya, or Table Mountain. This is a volcano born and shaped entirely by ice. The initial explosive eruptions under the glacier create a broad, flat base of fragmented rock, known as a hyaloclastite. As the eruption persists, it eventually melts through the ice, creating a meltwater lake capped by the remaining glacier. In this subglacial lake, the eruption can transition to a quieter, effusive phase, pouring out lava that cools into solid, columnar-jointed basalt. The final result, once the ice age ends and the glacier retreats, is a singular, flat-topped mountain with sheer, cliff-like sides, a mesa forged in ice and fire. These solitary, table-like peaks in places like Iceland and British Columbia are the silent monuments to ancient frozen battles. The interaction is not always purely explosive. Sometimes the heat of the magma is enough to simply melt a vast cavern within the ice, a huge hidden vault of meltwater. These subglacial lakes can be immense, holding volumes of water that rival small seas. If the volcanic activity ceases, this water may remain trapped, a dark, secret world under the ice. Or it may be suddenly released in a catastrophic event known as a jökulhlaup, an Icelandic term for a glacial outburst flood. A jökulhlaup is a terrifying phenomenon. When the ice dam containing a subglacial lake fails, it unleashes a biblical torrent of water, ice, and rock. The flood can be sudden, carrying the power to reshape entire landscapes in a matter of hours, scouring out canyons, depositing vast sand-urs or outwash plains, and carrying icebergs the size of houses far inland. It is a second-order effect of the volcano's heat, a watery echo of its subterranean fire. We have witnessed these forces in our own time. The 2010 eruption of Eyjafjallajökull in Iceland was a classic glacio-volcanic event. The eruption under the ice cap produced a fine, glass-rich ash that was particularly hazardous to aircraft engines, leading to the widespread disruption of European air travel. The eruption was a stark reminder that in our modern, interconnected world, the consequences of a fire-ice interaction under a remote Icelandic glacier can ripple across the globe. Similarly, in the Cascades of North America, mountains like Mount Rainier are not merely capped with ice. They are fundamentally shaped by it. Rainier is an active volcano, and its immense edifice is sheathed in the largest glacier system in the contiguous United States. The primary hazard from a future eruption of Rainier is not necessarily lava or a towering ash cloud, but the generation of colossal lahars, volcanic mudflows, as the eruption's heat instantly melts millions of tons of ice and snow. These lahars would race down the river valleys, replicating the destruction of ancient past events that buried entire forests under mud and rock. The volcano's icy coat, therefore, is not a mere decoration. It is an active participant, a moderator, and an intensifier of the volcanic fury. It transforms the nature of the eruption, creating unique, explosive chemistries and sculpting landforms found nowhere else. It teaches us that the planet's destructive power is not limited to a single element. The most profound forces are often released at the boundaries, in the places where fire and ice, in their eternal dance, choose to meet. It is a reminder that our world is one of dynamic, clashing energies, and that from their violent embrace, new and astonishing landscapes are born. We have stood before the fiery birth of cinder cones and the relentless growth of shield volcanoes. We have witnessed the directed fury of pyroclastic flows and the explosive meeting of fire and ice. But there is a scale of volcanism that transcends all of these, a phenomenon so vast that its most characteristic feature is not a mountain it builds, but a void it leaves behind. This is the realm of the caldera and the silent, echoing power of the supervolcano. The story of a caldera is not one of construction, but of catastrophic collapse. It begins not with a small chamber, but with a titanic reservoir of magma, a subterranean sea of molten rock that can be dozens of kilometers across. This is not a mere heart for a single mountain. It is a blister on the planet's crust, a region of immense thermal energy that has been building for hundreds of thousands of years. For millennia, this reservoir fills.
Magma from the deep mantle feeds it, its composition often evolving into a thick, viscous, and explosively gas-charged rhyolite.
The land above it swells into a vast, gentle dome, a great, unassuming plateau. There may be hints of the fury below, geysers, hot springs, and constant small earthquakes, but the true scale of the system remains hidden, biding its time. Then comes the eruption, not a vertical jet from a single vent, but a fundamental failure of the entire roof over the magma chamber. The pressure becomes too great. The Earth can no longer contain it. The eruption begins along a series of ring-shaped fractures, and the ground between them collapses downward, like the piston of a colossal engine. This collapse opens multiple gigantic vents, unleashing the entire contents of the upper magma chamber in a paroxysmal event. What follows is an eruption of such magnitude that it defies human imagination. This is a VEI-8 event, a super eruption. It does not produce a plume, it evacuates the atmosphere. Truly immense volumes of magma, thousands of cubic kilometers, are blasted into the sky in a matter of days. The pyroclastic flows that race across the landscape are not confined to valleys. They are hundreds of meters thick and can cover an area the size of a continent. The sky darkens across the globe. The finest ash and sulfate aerosols injected into the stratosphere will encircle the planet, reflecting sunlight for years, plunging the world into a volcanic winter. Ecosystems collapse, and the course of life itself is altered. When the fury finally subsides, the landscape is unrecognizable. Where a vast volcanic plateau once stood, there is now a gargantuan hole, a caldera, from the Spanish for cauldron. This is not a crater formed by an explosion, but a sinkhole, a collapse feature. The ground has literally fallen in on itself, leaving a void that can be tens of kilometers wide. The examples are etched into the Earth's memory. Crater Lake in Oregon is a beautiful, smaller-scale example. Mount Mazama, a once mighty stratovolcano, erupted catastrophically around 7,700 years ago. The eruption emptied its magma chamber, and the mountain collapsed into the void, creating the caldera that later filled with pristine rain and snowmelt. The calm beauty of the lake today is a silent echo of that ancient world-altering violence. But the most famous and active caldera system on Earth is Yellowstone. The park we know, with its geysers and hot springs, is the thin, fragile skin over a still active magma chamber. The entire park is, in fact, a caldera, the remnant of 3 successive super eruptions over the past 2.1 million years. The last of these, the eruption of the Yellowstone caldera, ejected over 1,000 cubic kilometers of material and left a smoldering scar, roughly 50 by 70 kilometers across. The geothermal features we marvel at today are the surface expressions of the immense heat still radiating from that incomplete, slumbering giant below. The formation of a caldera feels like an end. It is the volcano's ultimate act of self-destruction, the emptying of its soul onto the surface. But in the grand cyclical rhythm of the Earth, it is also a beginning. The magma chamber, though partially emptied, is often still connected to the heat source below. In the centuries and millennia that follow the collapse, new magma begins to seep back in. This new influx can push the caldera floor back upward, creating a resurgent dome. It fuels the geothermal systems that make places like Yellowstone dynamic and alive. The caldera, then, is not a tombstone, but a promise of renewal. The incredible fertility of the volcanic deposits, once weathered, creates rich soils. Life slowly, tenaciously returns to the sterilized landscape, often thriving in the warmth of the geothermal areas. The cycle begins anew. The magma chamber may be recharging slowly, invisibly, for the next act in a play that spans millions of years. To stand on the rim of a caldera, looking into its vast, quiet expanse, is to feel the echo of a power that can reshape continents and alter climates. It is a humbling experience that stretches our understanding of time and scale. These are not mountains that pierce the sky, but absences that speak of a fire deep enough and vast enough to humble the very horizon. They remind us that our world is capable of changes far beyond our daily comprehension, and that from the greatest destructions, new worlds, quietly and patiently, are always being prepared. We have spent our journey so far in the language of science, tracing the paths of magma and the physics of eruption. We have listened to the tremor and measured the swelling ground. But for most of human history, we did not have these words. When the ground shook and the sky turned to fire, when the very air grew thick with ash and the scent of sulfur, the only language adequate to describe it was the language of the sacred. This is the realm where geology becomes mythology, where the volcano is not a natural phenomenon, but a god, a demon, a smith, or a gateway. Before seismometers and satellite data, humanity faced the volcano with awe and terror. And from that potent mixture, we wove stories to explain the unexplainable. We personified the mountain, giving it a name, a personality, and a purpose. We could not believe that such immense power was mindless. Surely it was the work of a conscious, volatile, and divine will. In the swirling steam and fiery fountains of Hawaii, the people saw the presence of Pele, the goddess of volcanoes and fire. She was not a distant, benevolent deity, but a passionate, jealous, and powerful being. Her home was the Halemaumau crater at the summit of Kilauea. The lava flows were her physical body, her tears, her hair. She was a shapeshifter, sometimes appearing as a beautiful young woman, sometimes as a frail old hag. The eruptions were her moods, her fiery anger, her creative passion, her destructive jealousy. To this day, offerings are made to placate her, and stories are told of her encounters with her sister, the goddess of the sea. For the Hawaiian people, the volcano was not an it, but to she a living, breathing, and deeply respected part of their world. Across the world, in the Mediterranean, the Romans looked to their smith god Vulcan. He was a more industrial deity, his power channeled and controlled. His forge was said to be beneath Mount Etna in Sicily, and later beneath the volcanic island of Volcano, from which we derive our very word for volcano. The rumblings of Etna were the sound of his hammer striking the anvil. The sparks that flew into the sky were the stars being forged. The eruptions were his temper, or the result of a dramatic quarrel with the other gods on Olympus. Here, the volcano was not a goddess herself, but the workshop of a god, a place of divine industry and creation, whose byproducts, fire, smoke, and ash, shook the mortal world. For many cultures, the volcano was not a home or a workshop, but a gateway, a portal to the underworld, to the realm of the dead, to a place of punishment or judgment. The Aztecs and other Mesoamerican peoples saw the smoking peaks of Popocatépetl and Iztaccíhuatl not just as mountains, but as frozen lovers, their story etched into the sky, with the constant plume of smoke from Popocatépetl representing the warrior's eternal funeral pyre for his beloved. In Japan, Mount Osirisen, whose name means Fear Mountain, is considered one of the gateways to the afterlife. It's barren, sulphurous landscape a perfect mirror of the Buddhist underworld. These myths served a profound purpose. They were the first models of risk assessment. A story about a jealous goddess like Pele explained why a lava flow might destroy one village and spare another. It was her divine whim. It created a system of taboos and practices that, intentionally or not, often kept people away from the most dangerous zones during periods of unrest. The myths provided a framework for understanding and, more importantly, for coping. If the volcano was a god, it could be appeased. You could offer it gifts, you could pray to it, you could perform rituals. This gave a sense of agency in the face of an otherwise uncontrollable and terrifying force. The stories also connected the volcano to the very cycle of life and death. The same Pele who destroyed with her lava flows also created the new land on which life would eventually return. Vulcan forged the weapons of the gods, tools of both war and protection. The gateway to the underworld was also, by its nature, a connection to the realm of ancestors and the source of spiritual power. In our modern age, with our satellites and our monitoring networks, we have peeled back the first layer of the mystery. We know about subduction zones and magma chambers. We can explain the chemistry of the gases and the physics of the flows. But have we lost something in that knowing? When we look at a photograph of an eruption from space, it is data. When an ancient person looked at the same mountain, it was a living entity. Perhaps the old myths were not wrong, but were simply speaking a different language, the language of meaning. They recognized that a force capable of such creation and such destruction must be addressed with something more than data. With respect, with reverence, and with a humble acknowledgement of our own smallness, the volcano does not need our stories to exist. Its fire is independent of our myths. But we, it seems, need the stories. We need to clothe the raw, terrifying power of the earth in narratives that our human hearts can understand. So the next time you see footage of an eruption, remember Pele, remember Vulcan at his forge, remember the gateway to the underworld. For in those ancient stories we find the enduring echo of the first human question asked in the shadow of a smoking mountain. Who is there? After the myths and the awe comes the reality of life. We have seen the volcano as a destroyer, a creator, and a deity. But for millions of people around the world, the volcano is not a spectacle to be observed from a distance, nor a legend from a forgotten past. It is a neighbor. It is the shape on the horizon that defines the weather, the source of the soil under their feet, and the constant, quiet question mark hanging over their future. To live in the shadow of a volcano is to engage in one of humanity's oldest and most complex relationships with the natural world, a perpetual calculation of risk and reward. The most compelling reason for this proximity is written in the very earth. Volcanic soil, or andesol, is some of the most fertile on the planet. The weathering of volcanic rock and ash releases a wealth of essential nutrients, potassium, phosphorus, calcium, magnesium, and a suite of trace elements that create a deep, mineral-rich loam. This soil is famously friable, retaining water well while also draining sufficiently, making it an ideal bed for roots. On the flanks of Mount Etna in Sicily, this fertility translates into renowned vineyards and orchards. On the slopes of volcanoes in Indonesia, the Philippines, and Central America, it supports incredibly productive rice paddies and coffee plantations. This is not just good land. It is land that can sustain dense populations and generate profound agricultural wealth. For farming communities, the choice is often simple: the certainty of starvation on poor land, or the risk of catastrophe on rich land. The volcano offers life even as it holds the power to take it away. Beyond the soil, the volcano provides other, more direct gifts. Geothermal energy taps into the very heart of the mountain's fire, providing a clean, renewable source of power and heat. In Iceland, nearly 90% of homes are heated this way, and geothermal power plants generate a significant portion of the country's electricity. In New Zealand, Italy, and Kenya, the same principle turns turbines and powers industry. The volcano's heat, which can fuel devastating eruptions, can also warm homes and light cities, creating a powerful economic incentive to remain nearby. Then there is the sheer weight of history and culture. Cities like Naples, Italy, and Kagoshima, Japan, have been built in the shadow of Vesuvius and Sakurajima for centuries. Generations have lived, died, and built their traditions there. To leave is not just to abandon a house. It is to sever a connection to ancestors, to a way of life, to a cultural identity inextricably linked to the mountain. The volcano becomes a part of the community's soul, a familiar, if temperamental, landmark. This deep-rootedness creates a powerful inertia, a psychological down payment that makes the thought of leaving feel like a greater loss than the abstract risk of a future disaster. This relationship necessitates a constant, unspoken negotiation. The people who live in these zones become expert readers of the mountain's moods, often developing a folk science that parallels the work of volcanologists. They note changes in the behavior of springs, the restlessness of animals, and the specific quality of the tremors they feel. This lived experience, passed down through generations, is a form of wisdom, a cultural adaptation to a dangerous but rewarding environment. In the modern era, this negotiation has become more formalized. Sophisticated monitoring networks provide early warnings. Detailed hazard maps paint zones of risk in stark colors of red and orange, informing land use planning and building codes. Evacuation routes are signposted, and drills are practiced in schools. Living in the shadow now involves a partnership with science, a trust in technology to provide the crucial hours or days needed to escape. Yet this very system can create a paradox. The better the monitoring and the more frequent the false alarms or small, non-catastrophic eruptions, the more a sense of complacency can set in. The volcano becomes familiar. Its small rumblings are part of the background noise of life. The cry wolf effect is a real and dangerous psychological phenomenon. The greatest risk is not always the eruption itself, but the failure to believe it will happen this time. To an outsider, the choice to live under such a threat may seem irrational. But from the inside, the calculation is different. It is a balance between the immediate, tangible benefits, the fertile soil, the geothermal heat, the ancestral home, the vibrant community, and the abstract, statistical risk of a catastrophic event that may not occur in one's lifetime, or even for centuries. It is a choice to embrace a certain intensity of existence. There is a palpable vitality to life in these places, a sense of being fully awake to the power of the planet. The beauty is sharper, the community is often tighter, and the appreciation for the fruits of the land is deeper, precisely because the potential for loss is so well understood. To live in the shadow of a volcano is to accept a fundamental truth about our place on Earth, that we are temporary guests on a dynamic and restless planet. It is to acknowledge that the same forces that grant us life and sustenance also hold the power to take them away. It is a choice not of ignorance, but of a clear-eyed, calculated, and deeply human trade-off. It is the decision to plant a garden on the slopes of a giant, knowing that the same fire that enriches the soil may one day awaken, but choosing to tend the garden nonetheless. In the long, fiery story of our planet, certain moments are frozen with a clarity that transcends time. They become more than geological events. They become human stories, etched not just in rock, but in memory. Perhaps no other eruption has captured this duality, the immense, impersonal power of nature and the fragile, intimate details of human life as completely as the one that befell the Bay of Naples in the year 79 AD. This is the Pompeii moment. Before that late summer day, the cities of Pompeii and Herculaneum were thriving Roman settlements. Pompeii was a bustling commercial town, Herculaneum a quieter, wealthier seaside retreat. Life unfolded with the vibrant, noisy certainty of Roman civilization. The mountain that loomed over them, Vesuvius, was not seen as a direct threat. Its slopes were green with vineyards, its interior believed to be long extinct. The warning signs were there: a powerful earthquake 17 years prior, tremors in the days leading up to the eruption. But they were misread, or simply accepted as the grumblings of a familiar landscape. Then, around midday on August 24th, the mountain tore itself apart. The initial phase was a Plinian eruption. A column of pumice and ash shot over 30 kilometers into the stratosphere, a terrifying, towering pine tree of darkness. For the next 18 hours, pumice stones, light as foam but relentless as hail, began to fall on Pompeii. They did not immediately kill, but they trapped people indoors, collapsed roofs under their accumulating weight, and plunged the city into a Stygian darkness. The air filled with fine ash, making it difficult to breathe. This was the slow, suffocating prelude. The end, when it came, was swift and utterly terrifying. The following morning, the eruption column collapsed. The first of several pyroclastic surges, a ground-hugging, superheated avalanche of gas, ash, and rock, raced down the flanks of Vesuvius. It reached Herculaneum first. The temperature of this surge was so immense, perhaps 500 degrees Celsius, that it instantly vaporized soft tissue and boiled brains. It carbonized wood and food and killed every living thing in an instant. Hours later, more surges and flows reached Pompeii. The people who had survived the pumice fall were killed in the same way, by thermal shock and asphyxiation. A fine, hot ash settled over everything, sealing the cities in a tomb of remarkable preservation. This is where the story transforms from one of pure destruction to one of astonishing, if tragic, creation. The very ash that killed and buried these cities became their time capsule. It encased buildings at their full height, preserved paintings on walls with vivid color, and captured the minutiae of daily life. The famous plaster casts were created centuries later when archaeologists poured plaster into the voids left in the ash by decomposed bodies, revealing the haunting final postures of the victims. A family huddled together, a man shielding his face, a dog writhing in its final agony. But it is the smaller, quieter details that make the moment so profoundly human. A loaf of bread, carbonized in a bakery oven, still stamped with the baker's name, sealer. A pot of lentils, abandoned on a stove. A political campaign slogan painted on a wall. An intricate mosaic of a guard dog, the words, "Cave, canem, beware of the dog," eternally warning visitors. Jewelry, coins, and furniture were left exactly as they were, creating a perfect, heartbreaking snapshot of a single day in the Roman world. The Pompeii moment, therefore, is a duality. It is the ultimate testament to the volcano's power to erase. Yet paradoxically, it is also the ultimate act of preservation. It is a window into the ancient world of a clarity afforded by no other archaeological site. We do not just know how the Romans built. We know how they lived, what they ate, what they valued, and how they died. The volcano in its rage became an unwilling historian. The lessons learned from this moment echo through the centuries. For science, Pompeii and Herculaneum provided the first detailed stratigraphic record of a complex volcanic eruption, allowing volcanologists to understand the sequence and behavior of pyroclastic flows and surges. It gave a human scale to the abstract power of a Plinian event. For society, it serves as a permanent, sobering lesson in complacency. The residents of Pompeii did not understand the true nature of the threat they lived under. They had no science to warn them, no evacuation plan to follow. Their tragedy is a stark reminder that beauty and fertility can mask a terrible danger, and that the absence of recent activity is not the same as extinction. Today,
Millions of people live on the modern slopes of Vesuvius.
The lessons of Pompeii are the foundation of their survival. The city is one of the most intensely monitored volcanoes in the world. Its hazard maps are detailed, its evacuation plans rehearsed. The memory of the Pompeii moment hangs over the region, not as a spectre of fear, but as a mandate for vigilance. To walk the stone streets of Pompeii today is to walk through a moment suspended in time. The silence is heavy with stories. You can feel the presence of the lives interrupted, the conversations cut short, the daily routines forever unfinished. It is a place that humbles the soul, a stark reminder of our own fragility in the face of the Earth's deep, untamable forces. The Pompeii moment is not just a story of an ancient disaster. It is a permanent dialogue between the past and the present, a plea from the ashes to remember, to respect, and to be prepared.
After the cataclysm, after the fire and the thunder, comes the quiet.
The eruption ends. The last tremors fade from the seismographs. The plumes of steam dissipate into the clean, high air. The mountain, once a vision of apocalyptic power, now stands silent and still against the changing sky. It begins to sing its lullaby, a song of deep, deceptive peace that can last for years, for decades, even for centuries. This is the phase of dormancy. To a human sense of time, this quiet is easily mistaken for an ending. The volcano is declared sleeping, and then, as the generations pass and memory fades, it is often assumed to be extinct. Life, with its irrepressible force, rushes in to fill the silence. The rich weathered volcanic soils become the foundation for villages, then towns. Forests cloak the sharp, new landscapes, softening the raw rock into gentle green contours. The very crater that once vomited fire might become a tranquil lake, its deep blue waters reflecting nothing but clouds. The mountain becomes a backdrop, a source of identity and beauty, its violent past fading into local legend, a story told to children who find it difficult to believe. This is the volcano's most potent deception. For deep below the serene surface, the truth is often very different. The magma chamber, though partially emptied, is rarely dead. It is cooling, yes, but it is also being recharged. From the deep mantle, a slow, persistent trickle of new, molten material may be seeping in, reheating the crystalline mush that remains. The system is not off, it is idling. The heart of the volcano still beats, but its pulse is now so slow, so deep, that it is imperceptible to all but the most sensitive instruments. This presents the most profound challenge in volcanology, defining the line between dormant and extinct. When is a volcano truly finished? The answer is as elusive as time itself. A volcano can remain dormant for 1,000 years, 10 times longer than the entirety of the Roman Empire, and then reawaken with devastating force. Mount Vesuvius was dormant for centuries before 79 AD. The Soufriere Hills volcano on Montserrat was thought to be extinct until its shocking reawakening in 1995, which buried the capital city of Plymouth. Dormancy is not a state of death, but of potential energy. It is a phase in the volcano's long breathing rhythm, the slow, deep inhalation between explosive exhalations. During this time, the signs of life are subtle, but they are there for those who know how to look. Fumaroles, small vents on the mountain's flanks, may continue to issue a gentle, constant breath of steam and volcanic gases. A faint, thermal whisper. The ground might still be warm. Hot springs can bubble up at its base, cherished for their therapeutic waters, yet all the while hinting at the fires below. For the communities living on its slopes, the lullaby breeds a necessary yet dangerous sense of security. The mountain becomes a part of their home, their culture, their daily view. The abstract risk of an eruption 100 years from now cannot compete with the concrete reality of a harvest due next month, or a child's birthday tomorrow. This is not ignorance, but a very human adaptation. To live in a state of constant high alarm is impossible. The lullaby allows for life to flourish. It seduces with beauty and bounty. And so during this quiet phase, a silent, technological vigil must be kept. This is where science becomes the counterpoint to the lullaby. Networks of GPS stations measure the infinitesimal swelling of the ground, the mountain's deep, slow breath. Sensitive seismometers listen for the faint, harmonic tremor that signifies the movement of magma at depth. Gas sensors analyze the chemical composition of the fumarolic plumes, watching for a shift that indicates fresh, volatile, rich magma is rising from the abyss. This watchfulness is a dialogue with deep time. It is an acknowledgement that human history is a brief flicker in the long life of a volcano. Our centuries of recorded observation are but a single page in its multi-million-year autobiography. A dormancy of 500 years is, to a geologist, merely a short nap. The volcano's lullaby, therefore, is a beautiful and necessary lie. It is the planet's way of healing, of allowing ecosystems and human societies to rebuild and thrive in the extraordinary fertility that the volcano itself has provided. But it is a lie that we can no longer afford to believe unconditionally. To live in the shadow of a dormant volcano is to live with a dual consciousness, to appreciate the profound peace and beauty of the present moment, while respecting the immense, slumbering power that lies beneath. It is to understand that the mountain is not a static monument, but a living system on a timeline we cannot fully comprehend. The lullaby is sweet, its melody woven into the lives of generations. But we must listen to it with one ear always tuned to the deep, silent rhythm of the earth, ready to hear the moment the music changes and the giant begins to stir from its long, long sleep. For hundreds of thousands of years, the volcano has been a symbol of growth, of power, of the Earth's relentless drive to build upwards. But the planet has two great opposing forces, the one that thrusts land towards the sky, and the one that patiently, grain by grain, brings it back down. When the volcano's inner fire finally dies, when the magma chamber solidifies into a cold, dark root, and the last fumarole falls silent, a new chapter begins. This is not a drama of fire, but one of water, ice, and air. This is the erosion of a giant. The moment the last pulse of heat fades, the mountain becomes a target. It stands tall, exposed, and vulnerable to the sky's soft, persistent tools. The process is so slow that to our eyes it seems as though nothing is happening at all. But given enough time, these gentle forces are more powerful than any eruption. It begins with the rain. Each drop seems insignificant, but over centuries, this gentle percussion is a relentless hammer. Water is a master chemist. It is slightly acidic, absorbing carbon dioxide from the atmosphere, and it begins to dissolve the minerals that bind the volcanic rock together. It seeks out weaknesses, tiny cracks, joints, and fractures left over from the mountain's violent birth. It seeps into these spaces, and when winter comes, it performs its most patient magic. The water freezes, and as it freezes, it expands with a force that can split steel. This freeze-thaw cycle acts like a wedge, prying apart boulders, shattering cliff faces, and reducing solid rock to fields of jagged rubble that tumble down the slopes, a landscape known as scree or talus. Then come the rivers. Born from rain and melting snow, they begin as tiny streams high on the mountain's flanks. They follow the paths of least resistance, but as they flow, they become tools of immense power. They carry the sand and grit of eroded rock, using it as sandpaper to scour and grind their own beds, carving deep, V-shaped valleys into the volcano's flanks. A single river system can slice a mighty stratovolcano into a complex of sharp ridges and deep gorges, dissecting its form like a sculptor revealing the shape within the stone. The wind, too, adds its voice to this quiet chorus. On exposed ridges where no soil has yet formed, it carries fine particles of sand and dust. This constant, abrasive sandblasting can polish rock surfaces to a high sheen, etch intricate patterns, and slowly, imperceptibly, lower the summit itself. The wind is the artist of minutiae, working on a canvas of millennia. In colder climates or at high altitudes, glaciers take up the work. These rivers of ice are the most dramatic sculptors of all. They are not content with carving valleys. They reshape them. A river cuts a narrow V, but a glacier, with its immense weight and embedded rocks, grinds out a broad, deep, U-shaped trough. It quarries entire cliffs, plucking boulders from the mountainside. At the head of the valley, it carves out vast, amphitheatre-like hollows called cirques. When a volcano has been heavily glaciated, its sharp peak may be ground down into a horn, and its slopes transformed into a series of artful, sweeping valleys. The raw, jagged profile of its youth is smoothed into something more elegant, more austere. As the sharp edges are worn away, the volcano's true internal structure is often revealed. The central conduit, once filled with hardened magma, is often more resistant to erosion than the surrounding layers of ash and lava. Over millions of years, as the softer material is washed away, this ancient throat of the volcano may stand alone as a solitary, towering spire, a volcanic lek. A ghost of the fiery pathway that once was. The landscape softens. The steep, dramatic angles of a young stratovolcano give way to the rolling, forested hills of a mature and then ancient mountain. What was once a terrifying, fiery giant becomes a gentle, familiar presence on the horizon. The soil that was once sterile rock now supports lush ecosystems, all fed by the nutrients the volcano provided and erosion released. This is the beginning of the end, but it is an end that is also a transformation. The mountain is not vanishing. It is being redistributed. Every grain of sand carried by the river, every particle of silt suspended in the wind, is a piece of the volcano beginning a new journey. These sediments will travel downstream to be deposited in floodplains, to build deltas at the mouths of rivers, to form new layers of rock on the seafloor. The volcano that once built islands from the ocean floor is now feeding the continents, enriching the lowlands, and contributing its essence to new landscapes. The erosion of the giant is a humbling lesson in perspective. It teaches us that the most enduring changes are not always the most violent. The slow, patient, and gentle forces of the world, given enough time, can humble even the tallest peak. The fire built the mountain in a spectacular but geologically brief moment. The water and the ice will take it apart over an expanse of time so vast it challenges imagination. It is the Earth's great cycle of return, a quiet, relentless song of dissolution that sings the giant slowly, gracefully, back to the earth from which it came. After the fire has cooled and the last whispers of steam have faded from the rock, a new silence falls. It is a silence of absence. The land lies scoured, sterilized, and stripped bare, a canvas wiped completely clean by the planet's fury. It appears to be a place of endings. But in the heart of this apparent emptiness, a different story is waiting to be written. It is the oldest story on Earth, the story of life's return. This is the Green Return. The first actors in this slow, patient drama are so small you might miss them. They are the pioneers, the hardy colonists of barren ground. The first to arrive is often a simple crust of life, a lichen. Part fungus, part alga, a lichen is a symbiotic miracle. The fungus provides a structure, a grip on the bare rock, while the alga, within its protective embrace, photosynthesizes, creating food from sunlight and air. It needs no soil. It can survive extreme drought and temperature swings. It begins its work invisibly, secreting weak acids that etch microscopic grooves into the volcanic rock. The very first gentle act of weathering that will, in time, create soil. Alongside the lichens come mosses. Carried as tiny spores on the wind, they settle in the minute cracks and hollows where moisture might collect. They form soft green cushions that hold water like a sponge, creating their own tiny, humid microclimates. As the lichens and mosses live and die, their organic matter mixes with the mineral grit created from the weathering rock. This creates the first, thin, fragile layer of soil, a mere film over the stone, but it is a foothold. It is a beachhead for life, established against all odds. With this thin soil comes the next wave. Hardy flowering plants, often with seeds designed for travel, feathery parachutes like the fireweed, or tough, resilient seeds that can lay dormant for years, waiting for their moment. These plants are specialists in poverty. They have deep taproots to seek out water and nutrients, and they can thrive in the full, harsh sun of the open ground. They are the first splash of colour, the purple of fireweed, the yellow of alpine mustard, a declaration that the green world is here to stay. Their death is as important as their life. Each season, as these pioneer plants perish, they add their bodies to the growing layer of organic matter. The soil thickens, becomes richer, and holds more water. It is a virtuous cycle, a slow-motion feedback loop of fertility. The land is literally building itself from the bottom up, using the minerals the volcano provided and the carbon the air provides. As the soil deepens, the character of the life it supports changes. Shrubs and small trees can now take root. Alders and other nitrogen-fixing plants move in, their roots working with bacteria to pull nitrogen from the air and make it available to other plants, further enriching the soil. The landscape is no longer a collection of isolated pioneers, but a connected community. This process, this orderly and predictable transition from one community to the next, is known as ecological succession. The return of the forest is the final act in this long drama. Shade-tolerant saplings begin to grow beneath the shrubs. As they mature, they create a canopy that changes the environment below, cooling the ground, retaining humidity, and dropping a rich leaf litter that continues to build the soil. Over centuries, a complex multi-layered ecosystem establishes itself. The sterile plain of ash is now a thriving woodland, buzzing with insects, home to birds and mammals that have followed the green trail back. The speed of this return is a tale written in climate and isolation. On the slopes of Mount St. Helens, which erupted in a temperate, well-populated region, the green return was astonishingly swift, with plants and animals recolonizing the blast zone within years. On a remote, newly born volcanic island like Surtsey off the coast of Iceland, the process is far slower. A patient, centuries-long experiment in colonization over a vast oceanic moat. To witness this process is to understand the profound resilience of life, but also its deep dependency on the non-living world. The volcano, in its destructive rage, provided the raw materials, the mineral-rich rock and ash, that make this lush return possible. The destruction and the creation are two halves of the same cycle. The fire that cleared the stage also provided the nutrients for the next performance. The green return is therefore a story of hope, but not a sentimental one. It is a hope written in the slow, stubborn language of biology and geology. It is a testament to life's tenacity, its boundless creativity, and its ability to weave itself back into the fabric of a wounded landscape. The forest that stands on the slopes of an ancient volcano does not forget the fire. It is built upon it. Every leaf, every trunk, every creature that scurries in the undergrowth is a testament to the enduring dialogue between the living world and the rocky ground it calls home. The giant may be slumbering or even dying, but in its shadow, a quieter, more persistent force is always waking up. The great eruptions are long past. The fires that built the mountain have sunk deep into memory, and the relentless work of erosion has begun to soften its once jagged profile. But the volcano is not yet ready for silence. In the long twilight of its life, it still has a voice. It is not the roar of its prime, but a whisper, a collection of sighs and murmurs that are the last, fading echoes of its inner fire. This is the volcano's last gasp. These final breaths take many forms, each one a clue to the dying embers below. The most common are the fumaroles. These are simple vents, cracks in the mountain skin where the last traces of heat and gas from the cooling magma chamber escape to the surface. The superheated water within the rock turns instantly to steam as it reaches the lower pressure of the open air, creating the characteristic hissing plumes. They are the mountain's gentle exhalation, a sign that its heart, while slowing, is still faintly warm. The chemistry of these gases is a final message from the deep. They carry the signature of the magma that was rich with water vapor, carbon dioxide, and the faint, unmistakable, rotten egg scent of hydrogen sulfide. For a volcanologist, studying these gases is like taking the volcano's temperature. A change in their ratio or temperature can be the last, subtle hint of a final small pulse of heat from below, or the confirmation that the system is cooling towards final stillness. As water percolates down through the rock, it is warmed by the deep-seated heat and rises again, sometimes finding a path to the surface to form a hot spring. These are more gentle than fumaroles. They pool in tranquil, often vibrantly colored basins. The water, heated by the old fire, is infused with dissolved minerals, silica, calcium, sulfur, that it has leached from the volcanic rock on its long journey. As the water cools and evaporates at the surface, these minerals precipitate out, building beautiful and bizarre formations, terraces of white travertine, cones of grey sinter, or brightly coloured mats of thermophilic bacteria that thrive in the warm, chemical-rich water. These are the volcano's final works of art, created not with fire, but with warm water and chemistry. In some places, this residual heat is channeled into a more dramatic display, the geyser. Here, the underground plumbing is just right. Water fills an underground cavity, is heated to boiling by the deep-seated warmth, and suddenly flashes into steam, forcing a column of water and vapor high into the air in a brief, spectacular fountain. It is the volcano's last playful spasm, a final rhythmic reminder of the pressure that once built within it. But a geyser's life is finite. As the heat source cools, the eruptions become less frequent, less powerful, and then cease altogether. The geyser becomes a quiet hot spring, and then eventually just a dry, mineral-lined vent, a fossilized memory of a once great force. This gradual cooling is the true story of this chapter. The magma chamber, once a seething sea of incandescent liquid, has now crystallized into a solid, dark, and cold mass of rock, a pluton. The heat that remains is merely the residual warmth of that solidifying body, like the warmth of a stone left in the sun long after sunset. There are no new sources of fire. The mountain is living on its geological savings, and the account is slowly being depleted. For the life that has reclaimed the slopes, these last gasps become a resource. The hot springs become oases, places of warmth and mineral nourishment in a cooling landscape.
Animals are drawn to them.
Humans, too, have always been drawn to these places, seeing in them both practical utility and spiritual significance. They are sanctuaries, bathed in a warmth that feels both ancient and deeply comforting. To witness a volcano in this phase is to witness a great power in repose. The drama is over. The fear has subsided. What remains is a landscape of quiet beauty and profound tranquility, all made possible by the fading breath of the giant, the hiss of the fumarole, the shimmering heat of a hot spring, the occasional sputter of a geyser. These are not signs of life, but the memory of it. They are the final notes of a long and spectacular symphony held in the air for a moment before fading into an everlasting silence. The last gasp is a farewell drawn out over centuries, a gentle and dignified closing of a chapter that began in the planet's most violent and creative fires. The last fumarole has ceased its whisper. The final hot spring has cooled to the temperature of the surrounding earth. The geyser, which once pulsed with a rhythmic breath, now stands as a silent, mineral-encrusted monument. The great exhalation is over. The mountain has drawn its last breath, and now a deep and final silence settles in. This is not dormancy, not sleep. This is the end. The volcano's heart has grown cold. Deep beneath the serene slopes, the transformation is complete. The magma chamber, the once great engine of fire that fueled every eruption, every tremor, and every plume of steam, has undergone its final change. For hundreds of thousands of years, it cooled, its molten rock slowly crystallizing, one mineral at a time in a specific, unchangeable sequence. The last droplets of liquid rock have now solidified. The chamber is no longer a chamber, but a vast, dark and dense body of solid rock, a pluton. The heat that remained was only the fading memory of that liquid state, and now that too has dissipated, bled away into the surrounding crust, and carried off by the slow circulation of groundwater. The internal temperature of the mountain has reached a state of equilibrium with the crust around it. The fire is not sleeping. It is gone. With this final cooling comes a declaration that is both scientific and symbolic. The volcano is extinct. This is a weighty word. It does not mean inactive for a long time. It means that the geological conditions that created it, the subducting plate, the hotspot, the rifting crust, have shifted. The pipeline to the mantle has been severed and sealed. The mountain will never erupt again. The forces that built it have moved on, and it has been left behind, a relic of a more fiery age. The mountain itself is now just a mountain. Its identity has fundamentally changed. It is no longer defined by what it might do, but solely by what it has been. It is a piece of history, a monument to its own past. The slopes that were once the stage for cataclysmic violence are now stable, permanent, and utterly trustworthy. The ground will not swell. It will not shake with harmonic tremor. It is as solid and reliable as the oldest rocks on Earth. Erosion, which once worked at the fringes, now takes full command. With no internal heat to drive uplift, no new lava flows to armor its flanks, the mountain is now purely a subject of the sky. Rivers carve their valleys deeper. Glaciers, if they come, will grind down its summit. Wind and rain will continue their patient millennial work of reducing the peak to a gentle hill and eventually to a plain. The mountain is now on a one-way journey downward, its substance slowly being carried away to form sedimentary rocks elsewhere or to nourish distant lands. And yet, in its extinction, the volcano offers a final, profound gift, absolute stability. The very fear that defined life in its shadow, the uncertainty, the need for vigilance, evaporates. The soils it created, some of the richest on Earth, are now a permanent legacy. Civilizations can flourish on its flanks for millennia, without the geological underpinning of their world ever changing. The mountain becomes a benevolent, steadfast guardian, its fertile shoulders supporting generations who may only know of its fiery past, from ancient stories and the peculiar, dark stones they sometimes turn up in their fields. To stand on such a mountain is a different kind of experience. You are not standing on a sleeping giant, but on a tombstone. You walk on the cold, solidified skin of what was once a sea of fire. The rocks under your boots tell a violent story, but it is a story that is finished. The drama is complete. There is a profound peace in this, a sense of closure that a dormant volcano can never offer. The cold heart of the volcano is not a tragedy. It is a natural and inevitable conclusion. Every volcano, no matter how mighty, has a lifespan. It is born, it lives a turbulent life, it ages, and it finally dies. This extinction is the final stage in the grand cycle. The energy that was concentrated here has been spent, and the Earth's restless forces have moved on to other places, to other weaknesses in the crust, where new volcanoes are being born at this very moment, beginning the epic story all over again. The extinct volcano, therefore, stands as a silent teacher. It reminds us that even the most powerful forces have a beginning, a middle, and an end. It shows us that from the most violent chaos can come the most enduring peace. It is a mountain that has completed its journey, its cold heart a testament to a fire that once was, and a promise that elsewhere, under a different sky, the fire is always burning. From the first stirrings in the dark to the final cold silence, we have journeyed through the full life of a volcano. We have witnessed its terrifying power and its gentle generosity. We have seen it as a destroyer and a creator, a bringer of ends and a catalyst for beginnings. If there is one truth that emerges from the smoke and the ash, it is this. The volcano cannot be defined by a single moment. Its true legacy is written in the entirety of its cycle, a duality that is not a contradiction, but the very source of its profound influence on our world. The volcano's first language is one of raw, untamed power. It is the earthquake that shatters the ground, the pyroclastic flow that incinerates everything in its path, the ash cloud that blots out the sun and chokes the air. It is the river of fire that consumes forests and homes with an indifferent thermal gravity. In these moments, the volcano is the great reset button of the landscape, an agent of absolute and undeniable destruction. It reminds us of the fragility of our constructions and the sheer force that resides within the planet we call home. This is the legacy of fire, written in the scars on the land and the memories of those who have witnessed its wrath. But to see only this is to read the first page of a long and complex book. For the volcano's second and ultimately more enduring language is one of creation. The fire that destroys is the same fire that forges new land from the seafloor, that builds islands in a barren ocean, that adds new substance to the edges of continents. The very minerals that were locked in the mantle are brought to the surface, ground into ash, and poured out as lava, where they begin their slow, transformative journey. The legacy of this creation is all around us. It is in the very air we breathe, a primordial atmosphere shaped and replenished by countless volcanic outgassings over billions of years. It is in the water of the oceans which volcanic activity helped to form, and most tangibly, it is in the ground beneath our feet. The volcano's greatest and most humble gift is the soil, the seemingly sterile rock and ash, weathered by time and enriched by the cycle of life and death, become the most fertile land on earth. The dark, rich andisols that form on volcanic slopes are a cradle for civilization. The vineyards of Sicily on the flanks of Etna, the rice paddies of Java, the coffee plantations of Central America, the wheat fields of the Pacific Northwest, all are fed by the broken-down minerals of ancient eruptions. The volcano in its death gives life. The destroyer becomes the ultimate sustainer. This is the profound paradox at the heart of the volcano's story. It is the source of both the poison and the antidote. The ash that chokes also fertilizes. The lava that buries also provides the foundation for new ecosystems. The catastrophe that clears the land is what makes it capable of supporting a richer, more diverse life in the future. Destruction and creation are not two separate forces, but two sides of the same coin, the inhale and exhale of the planet's deep, geothermal breath. Our own human story is inextricably linked to this cycle. We have feared the volcano, revered it as a god, and built our communities in its shadow, drawn by the undeniable bounty it provides. Our cultures, our myths, and our agriculture are, in many parts of the world, fundamentally volcanic. We are creatures of the fire, our civilizations built upon the weathered legacy of ancient eruptions. And now, in our modern age, we have learned to listen to the volcano's voice. We have learned to read the tremors and the gases, not with superstition, but with science. This knowledge does not diminish its power, but deepens our respect for it. It allows us to live with the giant, to understand its rhythms, and to protect ourselves from its wrath, while still benefiting from its incredible gifts. The legacy of the volcano, therefore, is not just one of stone and soil. It is a lesson in perspective. It teaches us about the scales of time that govern our planet, where a mountain's life is a brief, spectacular event in a cycle of endless renewal. It teaches us about balance, showing that from the most violent chaos can emerge the most enduring stability and fertility. It reminds us that we are part of a dynamic, living system, one that does not exist for our comfort, but one that provides the very foundation for our existence nonetheless. So, the next time you see a mountain on the horizon or feel the rich, dark soil in your hands, or simply take a breath of air, remember the fire. Remember the long, patient journey from the planet's heart to its surface. The volcano's story is one of endings, but it is, above all, a story of relentless, resilient beginnings. Its legacy is the world itself, forever being shattered and forever being remade in a beautiful, unending dance of stone and fire.